Everyone, I'm Charlie Hoyt. I'm a postdoc at the Laboratory Systems Pharmacology at Harvard Medical School. And I'm a chemist by training, but a bioinformatician and a chemoinformatician now. And I really care about reproducibility in science, both on a technical and sort of philosophical level. So I'm going to try and squeeze down a talk that I've given several times before over a course of 3 hours. I'm going to try and smash it into 30 minutes. So I'm going to hit all the biggest most important points. And I'm going to give you a lot of the tools to do this stuff automatically. I'm going to actually teach it from the end. I'm going to give you the Martha Stewart treatment. I'll show you what happens when it's already done, and I'll kind of backfill and explain some of the things. Turns out a lot of packaging stuff with Python is a little hand wavy. Python packaging isn't really the same thing as programming. It doesn't have the same core set of skills. It doesn't have the same ideals as what a research programmer might end up doing. But we want to take those sort of bars away by giving you an example. And if you're like me, you'll just copy paste the same thing that you used the last time every time you start a new project, and you don't ever have to think about it again. But having this background just to know what's inside there in case you ever need to troubleshoot is super helpful. So first thing I'm going to do is I'm going to link you to the page on my website where I have a link to the long version of this talk. So I've given it twice when it was recorded, so you can consider rewatching it there if this wasn't enough for you. And I'm going to do this entire talk basically just live streaming what's on my screen, and we're gonna kind of go from there. So feel free to jump in and say something, though keep in mind we only have 27 minutes left. So if you ask a lot of difficult questions, it may mean we can't get to some of the things that we wanted to. So yeah, let me just do some coding in front of you and let's see how that goes. The first thing, I've got this machine learning library I work on called PyKeen for knowledge graph embedding models. And we're doing some benchmarking these days. And so I created some results from benchmarking some stuff. And actually I want to write a very short script that summarizes the results. I actually did this already. I'm going to show you what the goal is that we're going to try and get to. So I want to create an image that looks sort of like this, make some, trellis bar charts. So let's say that I write the script that does this, So if you're not familiar, this is PyCharm, great integrated development environment. And let's say I probably need to import pandas, need to import Seaborn. And then I need to start writing my code. So first I should load up my data. Okay, where's my data? Oh, I already made a typo. You guys are also responsible for any typo checks. Let's see.
That's what you have PyCharm for.
That's what I have PyCharm for? Yeah. Okay. Okay, so I don't know. Let's say this is, all right, maybe I'm not gonna manage to do a full demo because this might take a little bit too long. So let's say that I wanna open up this file. And then, I don't know, so data equals JSON.load file. And then I want to print my data. All right, I've severely decreased the amount of stuff I said I was going to want to do in this. So let's just say I have a file that I want to load it up and do something with it. So we're just going to say we're printing it. I can run this, should be all right. Now you can see there's some results that came out. There's a big problem though. If rather than printing data, I actually did something interesting with this, and then I published a paper and said, hey, look at my code. This is great. User CD Hoyt dev, non-parametric, whatever. Big problem. Nobody has the same file path as me. So how do we solve this problem? This part of the demo is going to be how to use click to make a command line interface. And so the first thing that we should always think about doing is let's give our file path a name. It's not URL, it's going to be path. And then the next thing I think super important is every time that you write a Python script, you can kind of just execute code in it. But the part that actually does the hard work, I always wrap that in a function called main. So now if I run this Python file, it's actually not going to do anything anymore because my code's living inside this main function. So I need to call the main function. Okay, I'm going to run it again. All right, still does what we expect it to do. One problem though is we actually don't want to run code just floating around inside the module. What happens if this code does something very heavy, or if somebody accidentally imports this somewhere else, it'll actually run this. So we have this trick called if name equals main. If you're not familiar with this, inside Python, there's all sorts of built-in stuff that's available in the environment. And one of them is this dunder name. So dunder means 2 underscores, then something, then 2 underscores again. So this dunder main is always available. Dunder name is always available in every Python module. And depending on how you run it, it's going to either be called the name of the Python file, which is like demo.py, or if you're running the file as a script, it'll get set to main. So that's why this check is nice. Make sure that this code only runs when we're specifically running this demo file as a script and not if we're importing it. All right, so it still runs. It's still going to do what I want it to. This is good. The problem, though, is they still have this issue where there's a path. So we kind of want to abstract that away. And so here's the worst version of fixing this problem. Is let's say like, all right, we don't need the path anymore. We can import sys. And then we can say our path is sys.argv, argv1. Let's imagine now that I'm going to spin up my command line. Actually, let me just do it inside PyCharm to keep everything a little bit more controlled. So now if I do benchmark.py, now I can do, no, it's not benchmark, sorry, it's demo. So now I can do users ct hoyt dev on parametric runs, whatever, one of my files. Okay, so this is better than what we had before because now the actual name of the file is sort of abstracted out of the code itself. But this argv thing is really nonsense because if I don't know how to use this Python demo.py, the typical thing you do is you give it -- help. And I think if we do this, we're going to get some massive issues. Okay, no file or directory -- help. So the next thing that I'm not going to show a demo on is people will turn to this argparse module. And argparse is a huge mess. I'm just going to say, don't use it. Let's just go straight to Click. Click is a better way to do this. So what you do with Click is you use these things called decorators on your function. So you take your main function and you do a decorator, which means you do the @ and then you do click.command. Okay, that tells Click this is going to be a function that gets run from the command line. So it's going to do some magic. We can sort of annotate in a couple of things. So we can say click.argument, and we give it a name, path. And then the same thing, we give a variable inside the main function called path. So now Click does all the magical stuff we need to make sure that the first thing that shows up as an argument gets interpreted as a variable called path, and it gets pushed along. So let's go back and run this demo.py again. Oh, you know what? It just occurred to me, this could be quite small. Is it really hard to see the stuff on my screen? Let me turn it up a little bit. Okay, let's say that's better. All right, ready to run? Good, it does what we expect. The last step, I think maybe two other things you can do to make your command lines much better is rather than using an argument is to use an option. So rather than giving these sort of hard to read examples of how to use your script down here, I like to use these flags to give some context to what's going on. So if you do -- path with an option instead of an argument, then you have to use this flag. Now, normally options are optional, but this one is not. So we're going to do required is true because sometimes options aren't optional. Okay, the last thing I want to say about making command line interface is don't put all of the logic inside your main function. Make helper functions that do the hard work of doing all the analysis and just let the main function interact with those by pulling in the arguments from Click and then sticking them in the right place. So we can call this main helper path. Good, because now this analysis that you spent all this time thinking about how to write, somebody can import it and use it directly from Python rather than having to run your command line interface. All right, any questions about that? How fast did I manage to go? Well, maybe 10 minutes to get Click down, but I think this is a good place to start. So does anyone have any questions about this? Yeah, just jump in, please. You're on mute, Peter.
So we've done all our stuff using argparser or whatever it's called.
Yep.
Is Click better than that?
Yes, Click is better. And the short version of why Click is better is because it has sort of this declarative interface for how the arguments get put in. And I think a lot of people make bad programming choices when they use argparse, because you have to create this sort of stateful object, which represents the parser itself.
Yeah.
And you have to manipulate this stateful object to use this parse args function. You get out this namespace object. And then what happens is people tend to litter their code with references to this namespace object. Like, what I would like you to do is to think about anytime you have a function that uses this namespace, create a helper function that takes in the actual things that you want, and then use sort of this mediator, like this main function, to mediate unpacking that namespace object and putting it into the place that it actually gets used. Again, the point of this is for reusability of the helper function, which is something that somebody else could import from their Python code and run it the way they'd like to. The other problem is people tend to do the argparse thing like just as a global variable within the module. And then there's an issue with scoping, where some of the functions only can be run when there's this global state that's available. And it's a very hard question to sort of describe. And I was thinking about it before this, and I think it would be good to do kind of a follow-up blog post explaining exactly what I'm talking about, because this was a little hand wavy. Okay, so yeah, you can make command line interfaces inside Python modules, because Python is really wonderful and easy to create a Python file and just run it like I showed. But what I also alluded to is that we want to write code that other people can reuse. And I would kind of say that creating a Python file that lives in like a GitHub repository isn't the most reusable. What we want is code that's packaged, code that has enough metadata to describe how to get it, how to install it, and how to use it. And so now we're going to talk for the last, let's say 15-ish minutes about how to create a Python package. And more specifically, how to take your code that you already have and put it into this structure. Because basically what I'm going to do is I'm going to use what's called the cookie cutter template to create a whole directory structure that has the right metadata files, that has the right structure. And then you just have to stick your Python files in the right place. Then you'll be able to reuse this. So I'm going to give you a little bit of a demo on how that looks. And then I'm going to explain some of the metadata and kind of what's there, how you can update it if you have to. But usually it's got reasonable defaults, and you can just think about porting your code over to having the structure. So let's come back to the terminal. Sorry, I have to move everything around because of the Zoom. All right, so I'm going to go into my dev folder. First thing we're going to need to do is we're going to need to have pip install cookie cutter. I think everyone should be like familiar with pip installing stuff, so I'm not going to explain anything about that. Now, you can make templates that aren't for Python projects using a cookie cutter. It just happens to be written in Python, and we're going to make a Python project using it. But remember, those things are sort of separate. So if we want to make a new Python package, this is one way to do it, right? We can start with the cookie cutter, and we can ask it to use a pre-existing template. So we're going to use my template. It has all of my good ideas inside it. So GH means GitHub, and then this is sort of the repository on GitHub where the template is defined. So you can actually go and look at the template and try and understand how it's created. But now we're just going to run it, and it's going to ask us some questions. First, you've already downloaded this. Is it okay to re-download it? Yes. All right. What are we going to call our package name? Why don't we call it like test package? Package names should have like underscores in them. They shouldn't have dashes, right? Because this is the kind of thing you would import, and it needs to be a valid Python identifier. Now we can stylize the name. So maybe it's called like test package, capitals. This is a test package. I don't know. This isn't super important for now, but writing a short description in one sentence is quite useful for your package. Author name. Okay, it's auto-populating with my name because I have configuration for defaults on here. So you should type your name, your email, the organization where you're going to store this on GitHub. This is actually quite important to go with all the documentation. So it's going to be CT Hoyt. The repository I'm going to call test-package on GitHub. Typically, names of repositories use dashes on GitHub, but underscores in the Python package name. All right, and yeah, so do I want a command line interface or not? So I'm going to have it auto-generate one for me as well. Okay, we're done. We've basically created our package. We're ready to install it. So first thing we can do is we can cd into test package. Okay, I'm going to list all the things in it. Why don't we go into PyCharm and start looking at it from there? All right, great. So, oh, seem to be missing some stuff. One sec. Not listing some of the files in the directory. 1 second. Okay. Let's try starting this one more time.
It seems just like the dot files have been hidden.
Is it just not showing dot files? I know there's a ton of dot
I
files.
think it's just the dot files.
No, we're
there's more
missing
of
contributing, we're missing license, we're missing README. What's happened here? All right, PyCharm has failed me. I'm really sorry. This is what happens when you do demos. Oh, and there's something in the chat. Oh, thanks, Kevin, for doing some links. All right, so let me just kind of walk you through the structure of this. I hope it's easy enough to see everything in my browser. So the first thing is every Python package needs to have some metadata. So this is what happens in this setup.cfg file. Now, Sebastian alluded to earlier that there's lots of previous ways packaging has been done in Python. Unfortunately, it's a little bit unstable and it's still in its growing pains, but I think this is a really good way to do it. So let's open up the setup.configuration file and look at some of the stuff that's put in here. So we got the name of the pack. We've got sort of this metadata. So this is a config file. So it's got these kind of square bracket headers, and then it's got some key values inside it. So we need to have the information about the name. The version is going to start 0.0.1 dev. The description we typed in. The long description refers to the README itself, which again, sorry, it's not showing up in the left side. I'm not really sure what's going on. And then we've got some URLs associated with it that get auto-generated. This is what I mentioned about the GitHub, the organization and the package name. So anytime that people are using your package, it's easy for them to find everything about it. It's got information about the author, which is you. It uses the license information. So this one, this template by default puts the MIT license. You're free to obviously change that to whatever you want. This license key uses what's called the SPDX license identifier, which is controlled vocabulary for licenses. And then this license file corresponds to the license file itself. Sorry, again, it's not showing it. Let's double check into that license file. And it's just going to show the MIT license. It's going to start with the current year. It's going to stick your name into it for you. Then we've got some other metadata that's like structured about the package, which says something about the programming languages it's able to be run on. So like which versions of Python, what the license is. Again, just a little bit redundant, but you know, and some other stuff. So you can sort of add your own topics from this list, and then you can add your own free text keywords under the keywords. So I left a lot of to-dos for you, so you can check. Next thing is the list of all the installation stuff that your package needs to run. This is complete replacement of requirements.txt. You should never, ever use requirements.txt for everything except for very, very specific instances when you're making web apps, I think is maybe the only time. So yeah, this is where you write all of these. Oops, sorry, we're jumping around. Yeah, this is where you write all of your requirements. You can also specify a little bit of more stuff besides just the names. You can pin version numbers. You can give version ranges. You can even do a little bit of logic about on which version of Python some things get installed. Like if you want to provide backwards compatibility, but you need to have a backport package. Next, some options you should always keep the same. Zip safe should always be false. This is a default that's wrong. That needs to be overridden. Same thing with include package data. You give it the minimum Python version. And now I'm going to do a little bit of hand waving for these couple lines of code because there's kind of a big argument about how Python packages should look. And there's only one good answer, but there's a lot of support for wrong answers too. So you can see there's the source directory. Inside the source directory, there is the name of the Python package, and then all of the Python code goes inside there. To support packages that look like this, you need to use these 4 lines that tell the setup configuration how to install the code that's inside your source directory. Now, why do we use the source directory format instead of just having the name of the Python package go inside the root directory of your repository? Well, if you do the second thing that doesn't use the source directory layout, then you can accidentally import, because Python's able to import just anything that's in the current working directory. You don't want to accidentally import stuff that hasn't been properly packaged. And if you don't use the source directory layout, you can fall into that trap, and it's very hard to debug, and it's going to cause a lot of issues. So that's the short version, right? There's a lot of other good reasons, and I will send you a blog post that references 3 or 4 other blog posts of maybe the smartest Python packaging people and why they think that this is the right way to do it too. All right, moving on. There's also a way to sort of have some optional extra requirements inside here. So I write down what are the things I need to run my tests and to build my documentation. There's this other part, we'll come back to that, it has to go around with making your command line interface. And then I'm not going to go over the rest of this. This is like configuration for some other packages that go with quality assurance. So let's double check. Yeah, I think the reason why this isn't working properly is because I've made another folder called test package somewhere else before. So let's see if that's the reason why we're having this issue. Good. Sorry, I'm just doing one more second of jumping around. PyCharm was a little bit too smart for its own good, I think. So here we go. Now we're back in PyCharm with everything. So this will be a little bit easier. How much time have I got left? I've got a little less than 10 minutes. So I talked about the metadata that goes inside setup.cfg. I talked about the structure of the Python package. So basically what you can do is you can start sticking all of your Python code inside the source and then your test package inside there. So this package already comes with a couple of things pre-built for you. First, it's got a version number. So this lets you import the version number like quite simply. There's better ways to do this. I'm going to change this about this template later. It automatically creates a command line interface with some documentation that explains what's going on here using click, and it makes it possible so you can already start sticking your Python code into here. And then, what you can do is you can import, from test package. Hold on, I have to mark this as sources root first. So from test package.api import like my function. So you should implement all the stuff maybe in a different place from where you write this command line interface. And then inside the command line interface, you could start using the function to do stuff. Okay, so yeah, now you can imagine like this is where you can define your function, maybe f. So this is a very simple package. In its API, it just has f, which does like x squared. And then maybe inside the command line interface, you import f. And then we're going to make a click.argument, which is getting my x. And we're going to print f of x. Okay. I think that was good. Easy to follow. So let's go into the terminal again. Let's activate some. Let's make a new environment. Or maybe I should have started with one I already had. Okay, so I'm inside my test package and I can do pip install dot. It's going to install the code that I have inside because it's got a setup.cfg. So it's already got some requirements that actually we're not going to use, but it'll take care of installing all those. And now we can do Python -m test package 5. Didn't work. What did we miss? Oh, there might be a typo somewhere actually. Oh, sorry. All right, so well, anyway, here's our. What am I missing?
You have the function print fx. Do you define f somewhere?
Yeah, we defined f inside this API Python package, and then we imported it in here. Okay. What have I forgotten? Click.command, click.argument, missing command. I think it's just having a little bit of an issue.
It's weird in the help string. It puts the argument in front of the command. Whether there's x, like in the help string, it says task package options x command. So I'm not sure why this is happening, but that's what's wrong.
Let's do option. I think it's just because PyCharm is having, my laptop's getting a little old and sometimes PyCharm doesn't refresh very quickly. So yeah, wow, okay. So
You need to do pip install -e to
yeah,
keep
all
your
right. So
code changes
there's
up to
another
date.
part of pip install. So if you do -e, it installs it in editable mode, which means that yes, it means that anything that you change inside the code actually gets reflected in the installation. You don't have to keep installing it. Thank you. That is the solution.
I think that's a useful emphasis to have on that point, given the number of times I've done that myself. So.
Yeah, and I almost always install with -e because I'm always in editable mode when I'm installing locally. So maybe you should remember that. In fact, it's the case that the README gets auto-generated in a way that has an explanation about how to pip install -e. You know, to install in development mode, do this. So let's try that again. Let's print our 25. Okay. So there's another thing that kind of happened here that I glossed over, and I see that we're sort of getting towards time, but maybe if you can give me an extra 5 minutes, I think people would probably be happy with that. So we've got this CLI.py that lives inside our package, and that's where the command line is actually implemented. But I create this function called main. Now there's another special Python module called dunder main, and what happens is you can import the command line interface and run it. And anytime you do python-m test package, it looks inside your test package for that dunder main file, and then it runs that as a script. So this is a really clever way to make it possible for people to run scripts that are packaged inside your code. So you don't have to have that kind of extra Python script that lives alongside of your packaged code. All right, a couple other things, random remarks. So that's kind of how to get packaging right. There's one other bit to packaging, actually. There's this pyproject.toml. And you actually have to have these first 3 lines that tell it, hey, we don't have a setup.py because we are part of the future. We're using sort of new style installations. And this is just a reminder that if there's no setup.py there already, then you should just use setup tools the same way that, like, if you have a very simple setup.py. This other stuff is just more configuration for black and isort, which I'd love to like spend a lot of time telling you about because I think it's really important to use black and isort to just make your code have a consistent style. So you don't have to think about that stuff. So that's already packaged in. So there's one other thing that's kind of here is this Tox configuration. And if you're familiar with make files, it's like a very general system on Unix that lets you define some tasks that kind of get run. Tox is like Python's packaging and project specific version of make that's really good at taking care of installing stuff and running Python related tasks. So basically what you do is you pip install Tox, and then you can start running some stuff from your Tox configuration. So we can run tox-e py, which runs all the tests. So by the way, this template comes prepackaged with a testing directory. So you can start adding your tests inside here. And Tox is smart enough to know how to run all of those in a very standardized way. And on top of that, there's this GitHub folder. So if you're on GitHub, it's going to automatically run the tests every time you make a commit. It's going to give you some feedback. So the first time it runs it, it has to, okay, so this is only a very simple test. So it passed. The test just imports something and then checks that it actually exists. You'll want to write something more complicated than that. So yeah, Tox is taking care of installing the package. It's taking care of installing the requirements. It's taking care of installing all the stuff it needs to run the tests, and then actually doing the tests itself. So we can look inside the Tox configuration, and this is sort of what that configuration looks like. So this -e py tells you to run the Python environment, which is sort of the default one. That's this. We can also run tox-e lint, which I have set up to run the black and the isort auto reformatter tools. So it'll basically take care of making your code look nice, or at least consistent. And this is really important for research groups. I think it's really important to teach young researchers who aren't Python programmers or programmers by heart, because they're going to write code that looks like a mess. And this is going to at least mitigate some of that. So you can see it, I actually write kind of in black compliant style by default now. So it didn't really change anything, but if it needed to, it would have, and it would kind of give a report on everything it changed. There's this other thing called Flake8. It's going to run some quality checks, make sure that you wrote documentation the right way. It's going to make sure that you have documentation. It's going to make sure that your code has passed the black test and that it passes isort test. It checks for some common bugs that people make. It's probably going to come up with a couple issues of things that I forgot, like not writing a doc string in this f function that I implemented. we shouldn't be using prints in general. We should be using like something like click.echo, and you shouldn't have prints littered around your code. Maybe inside a command line interface, it's okay to have some print functions, but nowhere else. You should be using like Python logging. In fact, there's a contributing.markdown file that's sort of auto-generated that gives some standard instructions on like the best way to write code, sort of in the scope of if you want to contribute to this package, you should kind of follow these rules. Like this is how you do contributing. This is how you do code style. Here's all the ways to run Tox. So this template sort of comes with an automatic set of instructions on how to use it as well. So yeah, there's a lot of stuff. And then here's what I was mentioning about logging, is that you shouldn't use print except when writing to files. And so there's this also part of Flake8 that's checking that you don't use print statements. And the other options are to use proper logging or to use click echo inside one of your command line interfaces. Okay, last bit. There's another function in Tox called tox-edocs. And this automatically builds a documentation for all of your code that you've written. So if you're being a good citizen, unlike me, because I forgot, because we're in the demo, you're going to write stuff like this: function returns x squared, right? So we're going to write nice doc strings. After we write nice doc strings, we want those to sort of get auto-generated into this beautiful HTML documentation that read the docs automatically will build every time you make a commit, and that anybody can go look at. So I can give you an example if you're not familiar with read the docs. Here's what PyKeen looks like on read the docs. Yeah, so you get these really nice things that kind of come out of the Python code and that you sort of use restructured text to make the outline for. All right, so let's open that up for the example that we just did: build docs. No, docs build. All right, so here's the documentation that gets automatically built kind of out of the package, out of the box. It has some explanation about the cookie cutter, it has a table of contents. You see it automatically makes some installation documentation for you. It automatically does some documentation about the stuff inside your main API. Obviously, you can start reorganizing your code however you want. This is a good place to start. And then it also automatically documents the command line interface. So this is like useful in a lot of cases. All right. Any final remarks? I know I've just done a total waterfall for everybody. Each one of these sort of has an entire explanation that needs to go with it, each configuration file. I didn't talk about bump version. I didn't talk about releasing to PyPI. It's a little magical, but whenever you're ready to release your code to PyPI, what you do is tox-e finish. I'm not going to do that now because I don't want to send something to PyPI that's called test package. In fact, I might have a demo though. So test release. Okay. I do have one. So you can do tox-e test release. And what this is going to do is it's going to build the package and it's going to push it to the test PyPI server just as a demonstration. And then the finish is the version of this that you want to use if you want to push it to actual PyPI. So yeah, now you don't have to think about any of the configuration or any of this metadata stuff or any of the code that you have to write to push to PyPI. I don't have the username on PyPI. Okay, sorry, I don't know what my username is there. So we'll just imagine that I'll type that in and then it says, okay, you're done. And then you can go to test PyPI and you can look at your package, and the same thing works with normal PyPI. All right, I'm 5 minutes over. I think we should still take a couple minutes of questions. I'm sorry for the guys who are waiting to give their talk, but I think I did so much that it would sort of be a disservice if we stopped right there. So please let me know some questions. I'll read through the chat.
Yeah, so thank you very much, Charlie. I can sort of direct those at you if that's easier. And I say we've got about 5 minutes, I think, Slack anyway, so we can use that for these questions. So, right, so I can read it if you want. So Seb has a question, or two questions actually. So one about done domain and whether there's any consensus on whether this approach is preferable to declaring an entry point in the setup.py, which I guess is perhaps more commonly used at the moment.
Okay, yeah, so you can have it both ways. So I showed you the example where I did Python -m test package, and this runs. But there was also this other thing that I sort of glossed over inside the setup configuration. Sorry, can you guys see the chat window or no? I hope not. So it automatically creates this sort of vanity interface. So when you pip install this, it's also going to install something called test package, like directly. So the question was, is one of them preferable? And I don't know what the answer is. This way, has it do both? You should probably try and choose a package that doesn't conflict with something else that's self-descriptive, but they can both coexist. All right, would you recommend using pre-commit to automatically trigger linting on commit? Yes, but I do not have any material or teaching material on how to make that work well. And I've run into problems with it. So typically I enforce that people make pull requests to code and that the pull request should pass all of the really difficult things that I've set up, for code quality assurance. And then you can sort of keep iterating back and forth. Yes. Pre-commit is a way to run all this stuff to force that people don't make commits that don't already pass. That frustrates people sometimes, and pre-commit sometimes a little bit unstable. So this is why I'm not going to make like a huge suggestion of it and why it's not built into this already, but that's a good thing to know about.
So Peter's got his hand up as well. I don't know if he wants to ask the same question as in the chat or if he has another comment.
Well, more or less just to say that was fantastic. I wish I'd known about this 6 months ago, because I have transitioned after 25 years of Java to Python, and it's very easy to shoot yourself in the foot in Python in many ways. I wouldn't have used argparse. I probably wouldn't have used requirements.txt and all this sort of thing. But, I take it on trust that these are better ways of doing it. But, we're still learning lots of better ways to do things. It's a very fluid environment.
So for you, Peter, having a group of university students, I think you have a university group, correct?
Not any longer. It's
okay.
mainly me. I rely on this type of operation. I have some wonderful collaborators who are going to talk in a minute, but they're still learning as well.
So the point I wanted to make is that the way that I've described this kind of makes it seem like as a research scientist, that you need to have this really massive set of knowledge about software engineering practices. And the point of this isn't to say that everyone needs to be a software engineer, but it's rather just that there are some ways to sort of decrease the burden of that, kind of reuse the same thing over and over again. This idea of the code quality assurance is quite difficult to push on people, especially if you just download this this template and it gives you 30 different things. This is, hey, you forgot documentation. You didn't write documentation in the imperative mood. I mean, if you're not a native English speaker, you maybe forget what imperative mood means, or if you forgot your 8th grade grammar class, maybe you don't remember that either. But it's all things that are trying to give good practices to make it easier for people to read your code, because it sort of homogenizes how everything looks. So be careful when you start introducing this to people. I think this core group, a lot of the listeners already have a lot of these core skills, and maybe this demo filled in a couple of things they didn't know. For some people, this is going to be a huge amount of new stuff. So, do your best. You're always free to get in touch with me. My contact information is all over on this template. And on the internet, you can find me pretty easily. I'd be happy to help. And yeah, this is only the first 30 minutes where we could have talked about this for 3 hours or even longer. So I'm sure there'll be lots of follow-up.